this is Mrs. Groves. This video is to help you with getting better at solving word problems. And the word problems that we're going to be covering are going to be solved using the graphing method. And these are going to be systems of equations. And what I like to do is have you get your book out and make sure you have rulers. And I am going to walk you through these problems, but I want you to do them on your own. So the front of this are two problems that are from your textbook. The first problem is on page 429, and the next problem is on page 430. On the back, there's additional practice problems. So let's start with this first problem. And what I'd like you to do is write these tips down. And then I want you to go through the problem and fill in the process to solving this system. Now here's an example where you're not going to have to solve the system. The steps that I want you to get used to are: 1, read the problem. I recommend that you read the problem fully 3 times so that you understand what the problem is. And then write the key information. And so down below here, I want you to write the key information. The second thing you're going to always do when solving these word problems is define the variables and remember units. Now, they've been nice to you in this problem. The variables are defined within the problem. You just have to find them. The third thing you're going to do is define the equations. I want you to write 2 equations, and here's a tip. Equation 1, write the equation with the pass. In equation 2, write the equation with no pass. And again, you do not need to solve this. So at this time, I'd like you to put it on pause and spend about 5 minutes going through and doing it on your own, and then I'll come back with the answer. I left this on for a little bit longer to make sure that you had time to write down all this information. I'm back. I hope you did well. The first thing I wanted you to do was make sure that you could find the key information. I wrote it here below. Okay, so the key information is that the pass is $90. Okay, and you pay $4 per quart. If you don't buy the pass, you pay $13 per quart. So that's the first thing you always do in solving a word problem. The next thing you do is you define the variables. Well, they were nice to you. They defined them for you. X, remember the units, it's the number of tennis sessions. And Y is the total cost in dollars. The first equation, the cost with the pass, total cost is Y. And each tennis session is X. So you paid $90 plus, was that a mistake? Let's see, that should be $4. Okay. And the cost with no pass, it's $13 for each time you rent the court, and that's the total cost. So this example helps you remember how to write key information, define variables, and define equations. Now we're going to go to the next problem. And I'm going to walk you through the steps that I want you to do. And you're going to do the problem on your own. And then come back and I'll show you the answer. So the first thing I want you to do is write the key information. The second thing I want you to do is know that the question helps you define the variables. And again, in this example, they were nice to you. And they defined the variables for you. Now, part of this question, make sure to read this little billboard here because that's going to help you with your key information. The third step is you're going to write two equations. Hint, one's going to be for rentals and one's for sales. The fourth thing you're going to do is you're going to graph both equations. Use X and Y intercepts to do the graphing. When you graph, clearly label the graph. Right? These are in units of 5, both on the x-axis and on the y-axis. Hint, this is going to be the number of skates rented, and this is the number of bikes rented. So you can sketch that, because I'm going to give that to you as a hint. Once you graph, you're going to estimate the point of intersection, and that's an ordered pair. Then you're going to check it to make sure that you have correctly found the correct ordered pair. Okay, and you're going to check the rentals equation and the sales equation. And finally, you're going to answer this question in words. So this question will probably take you about 10 minutes. So write these concepts that I want you to cover when you're solving this word problem down. And you can hit pause, and I'll come back and give you the answer. I'm back. So, the key information. Inline skates are $15 per day. Bikes are $30 per day. In one day, they had the following sales. They had 25 rentals between the bikes and the skates, and they earned $450 from renting skates and bikes. So, you have an equation for the pieces of equipment that were rented. You know that you rented 25, but you don't know how many were skates and how many were bikes. You made $450, but you don't know the number of skates and the number of bikes. You know skates are $15 and bikes are $30. So your graph using x and y intercepts, which is the easiest way to do this problem. So for the rentals, your x-intercept and y-intercept are both 25. So that's for the rental equation. For the sales equation, your x-intercept is 30 and your y-intercept is 15. And you graph them. And where they intersect, the point of intersection is 25. So the solution is the ordered pair 25. You're going to put this solution into both of the original equations. And so here you get 25 equals 25, and here you get 450 equals 450. For the rental equation, does it make sense? There's 20 skates and 5 bikes, totaling 25 pieces of rental equipment. Skates are $15, so you made $300 for skates. And bikes are $30, and you rented 5, so you made $150 there. So this equation checks because 450 is 450. When you're doing word problems, always ask yourself, does this make sense? And we just did, when we did the check, we saw that it did make sense. So the final answer is that in words, they rented 20 bikes. Excuse me, they rented 20 skates and 5 bikes. Okay, so that should be 5 bikes, 20 skates. I'll have to fix that on my notes. So that's those problems. Your homework is to do the problems on the back. If you don't have time to watch this video in class, you can watch it at home. And what I'm going to do now is go to the problems on the back. And I'm going to give you some tips on the back on how to solve these. Again, read the problems carefully. Here they define the variables. So those variables are going to be what are on the x and the y axis. So for problem number 1, the rocket ride, the number of 4 passenger cars are on the x-axis because that was defined as x, and the number of 8 passenger cars was defined as y. You need to define 2 equations, graph them, and then find their solutions. And write the answer in words. Hint, the first equation is the number of cars, and the second equation is the number of people. So those are the hints for the first for the first problem. I'm going to warn you that the second problem is going to have a graph that's going to be tricky to read. So you need to make sure that you check your answer to ensure that you have done it correctly. Here, they define the x and y variables for the fun problem. So x is adult dollars, y is child dollars. Graph it, find the solution, answer in words. The final problem is sweet. It's candy. Right? So the x variable is calories for chocolate kisses. So that is your x variable. Your y variable is the calories for caramel. And so you're going to graph it, find the solution, answer it in words. Now, you'll know if you've done this correctly because if you add the x and y coordinates, they're going to add, for these 3 solutions, 133. So, if you add this x and y, this x and this y, and this x and this y, those numbers will sum to 133. And all of the answers are are integers, so there's no decimals. So at this point, you're to do these problems for homework. If you're having trouble, you can check the answers by watching this YouTube video. So I'm back, and I'm going to show you the answers. For this problem, you had 10 cars. You didn't know how many were 4-passenger and how many were 8. So x plus y gives you your 10 cars. I graphed both of these with x and y intercepts. The second equation is the number of people in the car. So the 4-passenger car, which is x, has 4 people. Y is the 8-passenger cars, so that has 8 people. And that gives you a total of 56 people. I graphed the 2 lines. My ordered pair for the solution is 6, 4. So there are 6 4-passenger cars and 4 8-passenger cars. That's the answer to number 1. Now we're on to number 2. There are 2 groups that went to Funland Park. The first group had 2 adults and 5 kids, and the price that they spent for their group was $70. The second group, they had 4 adults and 3 kids and spent $84. For both of these, again, I used x and y intercepts. Told you the graph was going to be kind of tricky. So you had to make sure to check. Okay. The point of intersection is 15, 8. And if you checked, you would have gotten those answers correct in your 2 equations. So it's $15 per adult and $8 per kid. The last problem the 2 equations were kind of tricky. I used slope-intercept to graph both of these. The second one was really easy to do. Second equation, you have 3 kisses, so 3x plus 4 clusters, 4y, for a total of 360 calories. That equation was pretty straightforward. The other equation was a little trickier. The number of calories in a chocolate kiss is 20 less than the number of calories in a caramel cluster. So, a chocolate kiss the number of calories in a chocolate kiss is 20 less than the number of calories in a cluster. Okay? So these are the two equations that you could have gotten. Chocolate kiss is 20 more, or you could have subtracted 20 from the caramel. Graph it. There's your solution. It's 40 calories per chocolate kiss and 60 calories for caramel cluster. I know students have a difficult time with word problems. Hopefully watching this video and doing these problems has helped you. So long for today. And I hope you come back another day. This is Mrs. Groves signing off.